Hello everyone, welcome back to a new video. In front of me I have a big ol' rocket. This is my latest and first custom high power rocket. This is the TSP Panther. It's a 4-inch diameter, 38mm motor mount rocket that I built for around under $50. And I'm really happy with how the thing came out. I mean, it's super cool. Come on, look at this paint job. It's named after the greatest NFL team that's located in the Carolinas. And really happy with how it turned out. Can't keep saying, stop saying that. I mean, just look at how nice this lettering came out, the fins. It's really cool. And so, if you're curious about how I built this rocket, well, that's what I'm going to be covering in this video. So stay tuned for that. And I hope you guys enjoy how I built the TSP Panther high-powered rocket.
To me, the best first step in making a custom high-power rocket is to just make a simple draft, a rough draft. You start out with your main constraints, what you want to do with your rocket. In this case, I wanted a rocket that was high-powered, 38mm, and the material constraints, I wanted it to be able to be a 3D printed nose cone and to use a 4-inch packing tube as its body tube. And then from there, you can kind of go more in depth. You can make a little draft, a little sketch, help use Open Rocket to help yourself out. Go more in depth. You can start adding in, fin shape, fin tabs, that sort of thing, recovery systems, all that. And in doing this, it allows you to get a better idea of what you're going to have, what you need to order, what you need to buy. That way you can buy most things all at once, save on shipping, and also measure out these parts when you get them and make a more detailed design file in Open Rocket. That way you have a better picture of the stability. Once you have the materials, you're able to get accurate measurements and do all that.
So here I am doing some of that designing, as I said. By this point, I've already gotten most of those sketches done and the Open Rocket design done, but I'm here modeling out the nose cone, and I'll be able to put that into a Cura and get an estimate of how much it would weigh, which would also help with the Open Rocket design. And like I said, I really enjoy getting all the design done as soon as possible. That means I know what I'm going to order, and I can get all the parts done or ordered and to me as fast as possible so I can start doing the whole build at once.
Now you'll see we've cut out our fins. So this shape we got here, it's a very nice shape. I just chose it at random. That's how I always choose my fin shapes. Just whatever I feel like is going to be cool. Here we have our fin tabs that go in. We made sure that these would actually hit the, what's it called? The motor mount within the body tube. This is 1/4-inch thick eucalyptus plywood. This is the first big chunk of plywood that I saw, so that's what I got. So you just cut these out with a bandsaw, as you saw, sanded these off. Very nice and smooth. Now, here is the main body tube, as you can see. This is a 1/4-inch packing tube from Staples. And as you can see, you saw me cut out the fin tabs, or the slots, the fin slots. And so, of course, the fins will just slot in like so, and you can adjust them a little bit. And it's okay if these slots are not perfect. Obviously, we don't have a laser cutter, so you can't get perfect laser cut fin slots, but that's all right because we'll have a nice thick fillet of epoxy that will cover up all this sort of gappage, so there's really nothing to worry about.
Okay, so time traveling back, here I am sketching out the fins on this sheet of plywood that I got. Like I said, 1/4-inch eucalyptus plywood, what I got at home or Lowe's. Then I just cut them each of the fins out on a bandsaw and then sand them down, just smooth out the edges, even them all out on a circle sander. Then I'll sand them down smoother by hand. Now what I'm doing here, I have the body tube, and I have this line of dental floss. I'm using that to get the circumference of the body tube. And that way, do some little algebra here, mess up, do it right this time. That way I can mark out the lines for the fins. So I wrap that around and tape around the body tube, put up lines all across, and draw out where the fins will go. So then I take this drill press, right, and I have a 1/4-inch drill bit, and I drill out the ends of where the fin tabs will be. And then with a box cutter here, I cut from fin tab to fin tab, and that's how we get these through hole slots. They don't have to be perfect, like I said, because we'll just use some epoxy to make some large fillets that will cover up any of the gaps.
Here now we have our motor mount assembly. And it's pretty simple. Now, this body, it's a 38 millimeter motor mount that I ordered off Apogee, and these are some 38 to 4-inch centering rings that I also ordered off Apogee. I was debating 3D printing them, but plywood is tried and true for centering rings, and since this is such an important structural component, I decided I might as well just order them. And you'll see some hardware additions that I bought and I planned out to get. So up here we have this U-bolt here that's bolted in nice and tight. I'll probably use a little bit of epoxy. All of these will be filleted around with epoxy to make sure this is really structurally strong. And but this U-bolt right here, this will be holding onto the shock cord. This will attach to the shock cord. And then back here, what we have is 2 T-nuts. And so what we'll do is we'll have screws that come in, just like so. And we'll screw these in. I think I'm gonna have to go with larger washers, but pretty much the goal is, right, you'll tighten this over the engine or the motor that's coming out, and this will serve as the motor retainer, because buying a motor retainer is like $40 at this size. And then, of course, let's get all these parts back together. We're gonna have to make sure these align right with the fins, because these fins, again, are gonna be through wall. Everyone's gonna come in, and this will make a very strong structural assembly, especially with epoxy fillets all throughout. Obviously, this will be within the body glue that's coming. And so we'll just make sure that these line up so there's no like overlap between the fins. None of the fins are hitting this part. And yeah, this is going to be a very nice, strong structural design.
Using the drill press, I'm going to drill out the holes for the T-nuts so those can go in nice and smooth. Then I'm going to be sanding down, roughing up the edges where I'm going to be adhering the centering rings to the motor mount, and using some Loctite 9460 epoxy, lining things up, and then attaching these centering rings onto the motor mount like so. You'll see I'm using this coffee stirrer to make just some nice fillets, as well as using the fins to make sure everything's measured correctly.
Now for recovery, it's pretty simple. As you can see, we have this U-bolt. This is where the 10 feet that I bought of Kevlar, set number 750 Kevlar comes in. This is a nice, very strong shock cord. Gotta be able to, take it. It's burn resistant because it's Kevlar, and it'll be able to withstand strong injection forces. So this is very nice. This will obviously tie onto here and go through the rocket. Then we have a 12-inch Nomex parachute protector. So, this will just wrap around the parachute and it'll just help protect it. This is a quick link that will attach to the shock cord and, of course, the nose cone. This is way overkill, I'm not going to lie. But the quick link allows for rapid switching. Actually, I think I need to switch out and buy a different quick link, because I decided, instead of buying a new parachute, I might as well just reuse the one from my Apogee Zephyr kit, because it also has a quick link. So this is a 36-inch octagonal ripstop nylon parachute from Apogee Components. It came with the Apogee Zephyr. And these are really nice quality parachutes, and has a swivel right here to help reduce tangling. But as you can see, it does not fit on this quick link. So I will have to get a new quick link that is a little bit less ginormous, and will save this for maybe a more powerful rocket in the future. But the basic principle still stands. This attaches to the shock cord. This allows for me to switch out the parachutes between this rocket and the Apogee Zephyr. And I opted for that because they had the quick link, so I might as well use it, and it's much better than, I'm not going to be launching the two at the same exact time. I'll always have time to switch them out, and it'll save me like $30 from buying a parachute and all that sort of thing. And lastly, of course, the shock cord will finally attach to a giant, big ol' eye bolt. Again, this is a bit overkill, most likely, but better safe than sorry, of course. Ideally, you can get a forged, like, one-ring eye bolt that's much smaller, weighs much less, and has much higher strength and resistance. But because I couldn't find those forged ones, or I couldn't find those at the hardware store, I had to go for just like a single-piece eye bolt. And these usually have a lower working force load. So you had to get a bigger one to account for that. This is 160 pound rated, so should be more than enough, especially if you're comparing it to this little swivel. I feel like there's much more that will fail before this thing. And there's a whole assembly into the nose cone that I will explain next, but of course, this will just tie onto the shock cord. And that is really the entire recovery system. We're not going dual deploy or anything just yet. I'd rather start with a kit for dual deploy and try that out. But this is just going to be a nice, simple level 1 sized high power rocket.
So we take the Kevlar shock cord that we have, as well as the U-bolt on the motor mount, now that epoxy is all cured, and we just do a knot onto the U-bolt to connect that epoxy, or to connect the shock cord to the motor mount. I use some wood glue there just to make sure the ends don't fray and to hold the knot a little bit longer, like so. And then I'm going to be taking another drill bit and drilling into the main body tube. This will just be for the rail buttons. I bought those, and you just need to make holes that will fit them. You take those, as you can see there, you insert the bottom piece through the bottom, and then you have the little plastic rail button bit that goes over that metal piece, and then you just screw them in together, and then you use some epoxy just to hold them, extra strong, extra tight, because you won't be removing those rail buttons, so might as well just have the epoxy there to make sure they stay on forever. Now I'm using epoxy to actually attach the motor mount and the fins, so I put a nice helping of epoxy all throughout those sections where the parts will connect. Many points of contact there to make sure it's very secure. I use Loctite 9460 simply because that gun applicator makes it really easy to get into those small crevices. Here I stand up the rocket and use the 9460 to just make a little fillet across certain spots. Then I mix up some T88 epoxy. I chose this for the larger fillets. I first sketch out, line everything up, and tape off the sections for the fillets. But like I was saying, I use the T88 just because we have a larger quantity of it, so I think I could get a bigger, large fillet using it. I think for a lot of these applications, like a simple hobby store 5-minute epoxy would have worked, but since we have this epoxy, I might as well use it. We have a lot of the T88 and a lot of the 9460 because we're building the Kit Fox, and these are both aircraft rated epoxies, so the stronger the better here. But as you can see, I'm just applying these fillets like so. I use that coffee stir to get a nice glob of epoxy on there, then I'll use my gloved finger to smooth it all out. Now, moment of truth, we're taking off all the masking tape, the painter's tape actually, and we have all the epoxy fillets cured. You'll see there's some parts where the tape pulled off the body tubes covering, the paper covering, so I just used some wood glue there and I rubbed it in, then I'd sand it down and it makes a nice smooth surface. Lastly, I tie that Nomex parachute protector onto the shock cord.
Now I currently have my nose cone printing, and it's going to use up just about all my filament. It's huge, but while I'm at it, I'll show you these 2 test parts that I made just to make sure everything fit, and I'll show you the basic principle for how my nose cone will work. Now, I wanted my nose cone to be as long as possible, so it didn't look butt ugly on this rocket, which of course is going to be limited by the height of my 3D printer. So I decided that I would try to separate the shoulder and the nose cone into 2 parts. So this part is about 1 inch of shoulder, and then the nose cone would come out from this part, and there's this small slot, and this slot serves to connect the shoulder as well as the eye bolt. And then we have this part that will be testing the shoulder, but this would go out to be about a 4-inch diameter, and then I'll have walls coming out. It'll be hollow in here, but still fairly thick walls, so it should all be fairly strong. I'm printing it all in PETG. But anyways, the principle would be, right, you have this slot right here. The eyeball, the PLA is all threaded. I didn't want to just solely rely on threaded PLA in case that all tore. So we have this slot in here, right? And so obviously you'll have your washer go into the shoulder piece, and this would all screw in. I'm not going to do it. I've tested it before and it does work though. Yeah, so you'd screw it in. You'd slide in this washer here and then this nut, and then painstakingly line it up in the middle. Then it will all the way go through. That way, even if the threading, there's so much force that all the threading in this 3D print is, torn through, you still have this washer and this nut serving as a structural part, which I'd imagine would like the whole nose cone would fail probably before this part fails. So this ensures that this is a very sturdy nose cone, um, and that the excessive forces won't from like ejection and recovery deployment won't cause anything to fall apart. So there you have it.
Here we are printing this nose cone. It took like 2 days on the successful one. We had lots of failures before this.
You know what these are? These are failed attempts at printing this nose cone. This has been troublesome. It's not been easy. You can see the different infills I tried, and they just mess up. So yeah, I had to work with my printer a lot. We printed this in PETG, the nose cone and the shoulder section. The shoulder section actually came out really with no problem. And yeah, the nose cone was a little bit troublesome. Actually, some of these kind of go together. They're not like their own failures, but you get my point. And I messed up a lot. This one, come on. Oh. And this just didn't work out. I mean, I stopped it beforehand because I just didn't want to take risks, because this print would have used up all my filament, all the PET I bought. And it did. And so eventually we got it to work. And my saving grace there, I tried different infos, as you can see, grid, trihex. I, did some research. Gyroid is what I ended up using. And it worked out. There we go. This is our nose cone. This is the shoulder section. This is the nose cone. I have a clear line of tape connecting them at the moment. Here's our slot for the eye bolt assembly. You guys saw the test. Have all the pieces. I widen up this hole just a tiny bit so I can actually slide these guys in there with no difficulty, instead of having to like use a screw and a mallet to like move them around. Some imperfections, obviously. It didn't come out perfect. I mean, it's kind of like there's areas where it messed up. That's why I have a big old file. And so, yeah, I'm going to try to get this eye bolt in, to get this guy smoothed out. And then I'm going to mix up some T88 epoxy and just make a couple, get some on the threads of this, just so it never comes undone.
All right, now I'm actually attaching the eye bolt as well as the nut and the washer. It's a little bit of a tricky process, kind of getting it to fit into that slot, but I get it in the end with the help of some tweezers there. And then you see that file there. I use the file and some sandpaper to smooth out all the print lines of this print, and then I use an alcohol wipe to clean up all the sanding residue. Then I mix up some more T88 epoxy and use that just to connect all the final components, lock up the nuts and the washer. After I do that, you'll see I end up connecting the shock cord to the eye bolt on the nose cone. Now painting and finishing, very fun. Laid out this piece of paper, and then I just sprayed it black as my first coat. That's Rust-Oleum Painter's Touch 2X. I always say that. It always works as a great spray paint. Then I have these little letter stickers that I got out of Michael's, and I cut them out to have all the letters, Panther and TSP. I was going to go with stencils for this originally, but these were cheaper, and I figured they'd be easier once I spray painted these out, as you'll see, like so. Okay, onto that same sheet, I lay out all the letters. I use this like teal blue and some silver on the TSP and the teal blue on the Panther letters. Then I hit the other side of the rocket body with black, so I get it all covered. You can see I have really nice closed-toe shoes on, right? Very good. Just painting, it's fine. A little bit of a windy day, as you can see, which ended up being a little bit tricky. I folded and wrapped that piece of craft paper around the rocket body and then used masking tape to mask off the fins and nose cone, and then sprayed the teal stripes and the silver stripes on the nose cone and fins, respectively. With that done, I peel off all the tape and use a Sharpie to clean off any of the spots where it might have bled through. Just clean up all the lines, take off the paper that I used to cover the middle section, take off all the tape in the fin can, and boom, that's the spray painting all done. Last step is getting the stickers on, the letters on. So I lined those up like so, mess up the S, I just replaced that, put the Panther on, and there you go. Rocket all completed, and it looks great.
Now that you guys have seen the entire build, you guys should know the ins and outs of this rocket. Literally, you guys saw a lot of the internal components. Let me just ramble on a little bit more about what makes this rocket really cool to me. So I built this rocket, again, it cost me really like under $50. This nose cone was modeled by myself, very happy with how it came out. It is significantly heavy. This is like pretty much half the rocket's mass, so yeah, taking it does shift that center of gravity by quite a bit here. But it slides out just fine. The connection that I had shown works really well with the eye bolt in here. You got that. Since I haven't shown the entirety of this rocket completed, I'll show a little bit of it now. Yeah, you can see this completed paint job. Really looks nice. And yeah, that's all I can say. I'm really happy about it. I didn't really go into too much detail about the eye bolts here in the back. So I'll show you guys these now. I can't unscrew them all the way. But it's a 2-inch long machine bolt with a nut, a washer, and a nylon lock nut. And there's the two T-bolts that go into the centering rings here that are put into this rocket. And they just screw on in, and that's what retains the motor for the rocket. And I think this method works really well. It saved me a lot of money versus buying like a $38 Aeropack motor retainer. And it should do the job. I'm really happy with how the lettering came out as well. Here's the Nomex parachute protector, the shock cord. You see the eye bolt. I have my quick link right here. The parachute I have, like I said, I've taken off the Apogee Zephyr here, which is also a very similar rocket actually. It's also, it has a 3-foot long, 4-inch diameter body tube. Just slightly different profile, different mass, but this is a very tried and true kit for high power level 1 certifications. And I got this about like 2 years ago almost, and I'm gonna use it to get my certification just because it's a little bit more reliable. This rocket's never been launched by anyone in history before because I made it. But as soon as I get that certification, this guy's going up. It's fairly similar weight to this Zephyr here. This nose cone is, like I said, heavy because it's 3D printed. And 3D printed nose cones, a lot of weight, which doesn't hurt the stability. It actually shifts the center of gravity forward, which helps stability. But it just makes the liftoff mass of this rocket a little bit on the heavier side. So I think I'll be using a higher thrust H motor on my first launch, probably a Super Thunder because it'll also get a nice blue that matches. Comparing it to some of my previous rockets that I've built, this here was my very first rocket, the TSP Skyshrimp Light, and there's a simple low power rocket. There's actually a lot of interesting things that went into building this rocket. I have a little detailed history on it throughout this channel, but very small. I did lose the nose cone. This is my smallest rocket here, the TSP Mini. It's a tiny little rocket, and it is tiny compared to this thing. And then this was my largest custom rocket before I built the Panther, which it's still a decently sized mid-power rocket. It's on the smaller size for mid-power rockets, and it's just tiny compared to this guy. And then one more that's interesting, I've had some 2 stages, 3 stages all throughout, kind of interspersed throughout the middle. I lost the 2-stage sustainer and the 3-stage rocket sustainer, which is not fun. But this is the TSP Skyshrimp Medium, and the interesting part about that is that the body tube is the same size as the motor mount for this rocket, which is quite interesting, to say the least. So you compare all of my custom rockets, you can really see that this TSP Panther could probably swallow all of these whole, all these other ones whole. So that's really cool. But I'm really excited about how this rocket turned out, how it all came out. It was a very fun build process, and I'm really happy with how it looks all done. So yeah, guys, I hope you guys enjoyed the build and my little ramble. You guys got to see me in full for the first time. That's pretty interesting, right? So anyways, guys, if you guys enjoyed this video, I have more build ideas of some really interesting, unique, wacky rocket ideas that I want to actually build. They're coming on the channel. Launching this soon, probably in December is when you'll see it launched, just because that's when I'll be able to get out there to get my cert. But yeah, guys, if you guys like rocket content, like rocketry stuff, all that on this channel so far, more coming. Also, if you're curious about this little stand right here, I built this on the channel pretty recently, a little guide and tutorial, so shameless plug, check that out. And beyond that, I hope you guys enjoyed my video, and I hope to see you guys again in another video soon. Yeah, like, subscribe, comment, and share.